On the back side of the 8.1 applications of Pythagorean theorem is some problems on coordinate geometry. And so the question is, are the following triangles right triangles? So there are two methods that we can use here. The first method is to figure out the length of all three sides of the triangle and then use Pythagorean theorem to test whether those three lengths will make a right triangle. And so to do that, I need to figure out the length of AB, and I need to find the length of BC, and I need to find the length of AC. So one option is that we can always take the distance formula and use the coordinates of A, B, and C. So A is 4, -1, B is 5, 6, and C is 1, 3. So we can use those coordinates, put them in the distance formula to find the distance between A and B and C and A and C. The other approach, which is just a different version of the distance formula, is to make right triangles out of these lengths of the sides of the triangle. So side AB, if I make that the hypotenuse of a triangle that I can count 1 unit over, and then 1, 2, 3, 4, 5, 6, 7 units up, then this becomes the hypotenuse of this right triangle. And I can use Pythagorean theorem, which is just a variation on the distance formula, or where the distance formula comes from. And so AB can be found by taking 1 squared plus 7 squared, and then taking the square root of that answer. We can find BC. Well, let's go ahead and calculate that. So AB will be 1 plus 49, so this is the square root of 50. And when you're trying to test whether this is a right triangle, let's leave it as a square root rather than changing it into a decimal or trying to simplify it. Next, BC. So BC, if I can make that a right triangle, so I want to use a horizontal and a vertical line to make a right triangle that's 3 units high and 1, 2, 3, 4 units long. And so the right triangle, I take 3 squared plus 4 squared equals the hypotenuse squared, and then I'll take the square root of that to solve for the hypotenuse. 9 plus 16 is 25. Square root of 25 is 5. If it comes out evenly, sure, go ahead and simplify. Finally, side AC, so I use a vertical line and a horizontal line to make a right triangle. Notice that all of these together make a rectangle that goes through all 3 vertices of the triangle. So this triangle is 1, 2, 3, 4 units high and 1, 2, 3 units across. So again, this right triangle will be 3 squared plus 4 squared, and then we'll take the square root to get the hypotenuse by itself. 9 plus 16 is 25. Square root of 25 is 5. So square root of 50 is bigger than square root of 25 and square root of 25. So we want to check, is that the hypotenuse? So in a right triangle, we take short side, so one of these, 5 squared, plus the other short side, 5 squared, does that equal the long side, which is square root of 50, squared? And so what we'll notice is that when we square a square root, those two cancel each other, and so we're left with 50 on this side. 25 plus 25, 25 plus 25 equals 50. Yes, that is true. This is a right triangle. So that's the one approach. Now the second one is that if you can we can also use the slopes of the sides of the triangles, and if any of the slopes are perpendicular to each other, meaning opposite reciprocals, then this will also mean that we have a right angle and therefore a right triangle. So these same triangles that we just drew on the original one, we can use those to identify the slope. So the slope of AB is, I'm going up 7 over 1. Up 7 over 1. Rise over run, 7 over 1. The slope of BC, I'm rising 3, running 4. Rise over run. Notice those are both going uphill, so they're both positive slopes. But AC is going downhill, so the slope of AC, because it's going downhill, it's going to be a negative slope. I'm going down 4, right 3. So I'm falling 4, or rising negative 4, running 3. So as I look at these slopes, are any of them opposite reciprocals? And yes, the 3/4 and negative 4/3. So we change from positive to negative and we flip the fraction. Another way to test it is if you multiply the two slopes together, if they equal -1, then that means they are perpendicular, and that means that they make a right angle. So yes, triangle ABC is a right triangle. So there's our two methods. One, use the distance formula or Pythagorean theorem to find the length of all three sides, and then use Pythagorean theorem to see if this in fact is a true statement, then it means that it is a right triangle. Method 2, find the slopes of all of the sides. If any of them are opposite reciprocals, or they multiply to get -1, then that also indicates that those lines are perpendicular, making a right angle. So triangle ABC is a right triangle. So that's what you want to do for number 8. Is method 1, find the lengths of all the sides. Sorry, it's not a lot of space to work, but write small. Method 2, use the slopes to help you find whether there's any that are opposite reciprocals. In number 9, it says you're going to plot the point 8,4 on the coordinate plane and then connect the points to see if it makes a right triangle. And so you can choose which method you want to use to determine, does this make a right triangle or not. And finally, in 3 and 4 here at the bottom, you're given 3 lengths and you have to figure out, do they make a right triangle? And so again, we can use sort of the method that we used in method 1 to determine, once we know the lengths, determine if it's a right triangle. Does it fit Pythagorean theorem? Good luck.